In this video, we are going to consider the notation for the terms of the sequence, and also we are going to denote a whole sequence in a symbol. How we can do it here, you can see notation for the symbol, notation or a symbol for the objects of the sequence, and symbolization of the whole sequence. Consider the sequence here. One example, 3, 7, same one which I have considered earlier, and 11, 15, so on and so forth. This is a sequence which you have seen because each term, each number is obtained from the previous number by adding 4 to previous number. Now 3 we can denote it by T1 first term, and 7 second term, and 11 third term, and 15 fourth term, so on so forth. What about nth term? Instead of writing T1, T2, just they denote the position of the term, but not the symbol of the term. Now I am going to give the symbol first term by A1, second term by A2, and third term by A3, fourth term by A4, and so on and so forth. The nth term by AN, and this nth term to be determined in the next section. What we are going to do it, or any other symbols, or any other symbols or notations like B1, B2, B3, so on and so forth, Bn, or else C1, C2, C3, so on and so forth, Cn, or you may use x1, x2, etc., etc. And now, how to find out the nth term, I mean An or Bn or Cn, in the next section. Now the sequence above sequence which I can write down: A1, A2, A3, so on and so forth, An, so on and so forth. These are the symbols used for the first term, second term, so on and so forth. Now, as a whole sequence, how to write in the symbolic manner, that is, we write An, n equal to simply 1 to infinity, because if it is a finite number of terms are there in the sequence, if it is infinite, or An 1 to n if it is finite sequence. And for example, you can say 1, 2, 4, 6, 8, 10, 12. This can be written as An, n from 1 to 6. That is A1, A2, etc. A6. So there are 6 terms, therefore we can write down this sequence as AN from 1 to 6. Second example, 3, 7, 11, 15, 19, 23. This can be written as BN from 1 to 6 only. And third one, 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6, 6 by 7, 7 by 8, 8 by 9. This I can write down CN, that is 1 to 3, 3, 6 plus 2, 8. 8 terms. And fourth one, 5, 10, 20, 40, 80, 160, so on and so forth. This I can write down since it is an infinite sequence. So I can write down xn 1 to infinity, and so on. This way we can write down the sequence in terms of a symbol like AN 1 to 6, BN 1 to 6, and CN 1 to 8, and XN by 1 to infinity. The another example I would like to quote here, that is one simple example I am giving here. 1, 2, 3, 4, 5, 6, 7, 8. I mean sequence of natural numbers, which I can write down DN 1 to infinity. Now D1, D2, etc., etc. I mean D1 is equal to 1, D2 is equal to 2, so on and so forth. Similarly, in the other cases which you can consider. In this section, we are going to find out the nth term or a general term of the sequence. To find the nth term or general term of the sequence, now we can consider the two ways of writing the general term. There are two ways of finding the nth term, one by guessing and other by methodical way. For example, we can consider the same example which you have considered, that is 1, 3, 7, 15, 11, 15, 19, so on and so forth. What is that is A1, A2, A3, A4, A5, so on and so forth. AN. What is this? You can see here. As I have told, there are two ways of guessing this one. Now observe, each number in the sequence is an odd number. Then can you write down AN equal to 2n minus 1 or 2n plus 1, because that is an odd number. Each number in the sequence is odd. But these two will not hold in the sequence here, because if you take n is equal to 1, that is going to be the first term is going to be 1. If you take n is equal to 2, the first term is going to be, n is equal to 1, the first term is going to be 3, but the second term, n is equal to 2, it will give the 5, which is not there in the sequence. Then what? Then what? These will not fit into the definition of the sequence. Now you can see how you can write down here. The term is, each term is odd, so you can write down an is equal to 4n minus 1. This is also odd number. 4n is even minus 1 is odd. And also or 4n plus 1. If you take n is equal to 1, this is going to be 4n, 4 into 1 plus 1, that will give 5, and this is not. If you take n is equal to 1 in the earlier case, that is 4 into 1 minus 1, that is going to be 3. That is, here a1 is equal to 3. And what about a2? a2, n is equal to 2, 4 into 2, 8 minus 1, that is 7, and therefore nth term is 4n minus 1. This we have done it by guessing. Another way I have told, the methodical way, how to get the n term by a methodical way. You can see here, an is obtained from the previous term, an minus 1 plus 4. Okay, and now you can write down this as an minus 1 plus 1 into 4. Nothing wrong in writing so. And this an, I can write down an minus 2 plus 4 by the definition of the sequence, and plus 1 into 4, and this is an minus 2 plus 2 into 4. So you can go on doing so. That is going to be an minus 3 plus 3 into 4 plus so on so forth. I can write down an minus n minus 1, that is going to be a1, plus how much of quantity we have to add. Here 3 times 4. Here n minus 1 times 4. And what is this an minus 1 minus of an minus of n minus 1 means a1 plus n minus 1 into 4. a1 is 3 plus n minus 1 into 4, that is going to be 3 plus 4n minus 4. This is nothing but 4n minus 1. This is our nth term. This is the methodical way to find out the nth term of the sequence. Similarly, we can write down another example. 2, 5, 10, 20, 40, 80, so on and so forth. Now here, first term is A1, that is 5. Second term is A2, that is obtained from 2 into 5, okay, and A3 is obtained from 2 into A2, that is 2 into A2 is equal to 2 into 5, which I can write down 2 into 2 into 5, that is 2 raised to 2 into 5, and therefore this implies I can write down this is a A3 is equal to 2 into 2, 3 minus 1 into 5, and therefore AN is equal to 2 into n minus 1 into 5. This is the nth term, and similar fashion we can get the nth term here in another example, that is 1 by 2, 2 by 3, 3 by 4, and 4 by 5, so forth. Here observe the first term in which the numerator is 1, denominator is 2, second term numerator is 2, denominator 3, so one more than the numerator. First term is 1, and therefore nth term is n, and the denominator must be one more than the numerator. This is the nth term. Similar way, in a methodical way, I can write down that is an equal to Pn by Qn, and this is obtained from previous fraction by adding 1 to the numerator and 1 to the denominator. Like this you can go on doing so. You can get Pn minus n minus 1 by Qn minus n minus 1 plus 1 plus 1, and this is going to be Pn minus 1, that is going to be P1 by Q1 plus n minus 1 plus n minus 1, and that is going to be P1 by Q1 is 1 by 2 plus n minus 1 and plus n minus 1. Now observe, and this is n 1 plus n minus 1 means n divided by n minus 1 plus 2 is n plus 1. This is the way on which you can find out the nth term of the sequence. In the next video, we are going to consider some special method to find out the nth term of the sequence, that is called a telescopic method, which we are going to discuss in the next video.